In chapter 19, we're going to shift gears a little bit, and we're still going to talk about carbonyl chemistry, but we're going to see the reactions that are taking place not necessarily at the carbonyl, but at the alpha position. So we're going to see this importance of the alpha carbon. And to give a quick little preview of what I'm talking about here, we've already seen lots of nucleophilic addition reactions to the carbonyl carbon. And certainly, those are still very prevalent, and we're going to see those even in this chapter. But the focus of this chapter is going to be talking about the chemistry of what we call the alpha carbon. And just to kind of give you a definition of what we call the alpha carbon, if I have an aldehyde here, the alpha carbon is the carbon attached to a carbonyl. And I could be talking about a ketone, I could be talking about an aldehyde, I could be talking about an ester or an amide or any other carboxylic acid derivative. The alpha carbon is a carbon attached to a carbonyl group. And of course, the beta carbon is a carbon attached to an alpha carbon, and a gamma carbon is attached to a beta carbon, and a delta carbon is attached to a gamma carbon. So that's kind of how we classify the different types of carbons coming off of a carbonyl compound. And what we're going to see is that alpha carbon has acidic hydrogens on them. And we're going to discuss the acidity of those hydrogens and the resulting conjugate bases. So if I have a generic ketone in this case, and I have a hydrogen coming off of it. In this particular case, there are two hydrogens. I'm simply showing one of them. I'm going to see that that hydrogen can react with a base. It's acidic enough. It's a Bronsted acid. It can react with a base and undergo a deprotonation. So what's happening is the ketone or aldehyde gets deprotonated in basic conditions. We'll talk about the types of bases that we can use in just a little bit. But it establishes an equilibrium with the conjugate base. And this is the structure of that conjugate base, where it has a negative charge now on that alpha carbon. And we call these enolates, right? Enolates. So what we're going to see is that enolates behave as nucleophiles, right? I have a negative charge on a carbon, there's a high electron density, and guess what? We've seen that that carbonyl compounds react with nucleophiles, right? In a typical addition reaction where the nucleophile adds to the carbonyl carbon and you form that tetrahedral intermediate, right? Where now the nucleophile has added. And so depending on what the R groups are, if they're good leaving groups, they can undergo addition, elimination reactions, and if they are poor leaving groups, then they're simply going to get protonated in aqueous acidic conditions. Well, enolates are nucleophiles. So if I have an enolate, it can react with a carbonyl species and undergo an addition reaction. And so the result looks like this. So now I have this enolate that's present, and I can, depending on what the R groups are, I can protonate in acidic conditions, or if I have a good leaving group, I can reform the carbonyl and I get a beta keto, a beta oxo ketone, or sometimes a beta keto ester, or whatever. We're going to see a whole mix of things that can result from that. So one of the things that I want you to kind of think about as we're going through chapter 19 are the following questions. Number one, if a proton's removed from the site next to a carbonyl, right, that alpha carbon, how is the resulting anion stabilized by resonance? Always that resonance factor is contributing to stabilization. I should say typically contributing to stabilization. The second question that I want you to think about is what reactions can occur that use a deprotonated carbonyl as a nucleophile? right? So I showed you an example that um, ketones can react with nucleophiles. What other things can react with nucleophiles? And then the last question is, how is the reactivity of an alkene next to a carbonyl different from that of typical alkenes? And so we're going to see that when you have an alkene next to a carbonyl, those are called alpha beta unsaturated carbonyl compounds, they undergo reactions a little bit differently than your normal alkenes do and that your normal carbonyl compounds do. And these are some of the things that we have to look forward to in chapter 19.